Hello students, now we are going to see about frequency reuse concept in cellular system. First one, what is mean by cell? The large geographical area it is divided into a small geographical area is called cell, and each cellular base station is allocated a group of radio channels used with a small geographical area, and group of cells is called clusters, and here each cluster utilizes the entire available radio spectrum. Already we know that the radio spectrum it is only limited for the cellular uses, so we have to use this radio spectrum in an efficient manner. So that is the reason we go for that frequency reuse concept. The frequency reuse or frequency planning. So what is the meaning for this? So we have to use these same radio channels to the some other uses without interference. That is the frequency reuse. Here the frequency reuse is the process in which the same set of frequencies can be allocated to more than one cell, and the cells are represented or separated by a sufficient distance. And here the figure shows this is a cluster 1, this is a cluster 2, and this is a cluster 3. And see here, suppose we are having that 70 gigahertz radio channel. So each cell it is allocated the 10 channels. For example, 1 to 10 gigahertz channel is allocated to channel A. The same 1 to 10 gigahertz frequency channel is not allocated to B, C, D, E, F, because the interference will occur. So that the same radio channel will be allocated to the next cluster. See here, this is the next cluster. The same radio frequency channel it is used here. Likewise, the 1 to 10 frequency channel it is used here. So this is the frequency reuse concept without interference with the other channels. Capacity expansion by using frequency, and here we can calculate the number of full duplex cellular channels available in a cluster. So totally a single cluster it has 7 cells. So by using this we can calculate the number of cellular channels available in a cluster. So S is equal to K into N. So N is the number of cells available in a cluster. For example, we are having the each cluster we are having 7 cells. So we can have it as a N equal to 7, and K is equal to number of cells in a cell, number of channels in a cell. For example, we are having each cell contain it is a 10 channel, means totally it has a 70. So that is the S is equal to K into N. By using this we can calculate the capacity expansion for the cellular concept. And C is equal to M into K into N. C means it's a total channel capacity in a given area, and here by using this we can calculate the total number of channel capacity in a given area. So if we know the value of K, M and N, so by using this we can calculate the capacity of the system. So the C value you can easily calculate it. And this is a frequency reuse factor. The number of users use the same set of frequency is called the frequency reuse factor, and it is defined as the ratio of N by C. So N mean total number of channels in an area, and C mean total number of full duplex channels in a cell. So that is a N by C. The ratio between N by C is called frequency reuse factor. And the rule determining the nearest co-channel neighbor. How to allocate the same frequency channel to the nearest neighbor, and this is a rule. And first one, we have to choose any one adjacent cell. First one, we have to choose the move I cells along any chain of the hexagon. So totally each cluster we are having the 7 cells. We can move I cells along any chain of the hexagon. That is rule number 1. And turn 60-degree counterclockwise and move J cells. So that is step number 2. And see here, imagine that this is our cluster. Okay, so this is our cluster, and suppose this is a channel A, the same frequency channel where we can allocate means. So first we have to take I equal to any take adjacent channel. These are all the adjacent channels. So if I take this adjacent channel, mean I equal to 3, 1, 2, 3, and take 60-degree clockwise direction. This is if we have the by using this monitor, we can measure what is a 60-degree. So this is 60-degree. So J equal to 2, 1, 2. So J equal to 2 mean, so where the same frequency is allocated here. So 1 to 10 frequency gigahertz channel is allocated for channel A. The same frequency is allocated here. Like that, if I have chosen this is my adjacent channel, means I equal to 3, 1, 2, 3, and take 60-degree and choose the next frequency channel. It is a J equal to 2, 1, 2. So this is a next frequency channel. Like that, I can move all the channel. So this is a rule for determining the frequency reuse concept. And co-channel reuse ratio. The co-channel reuse ratio is defined by the D by R or else root 3n. If you know the value of number of uses or number of cells in a cluster, so we can easily calculate the co-channel reuse ratio. So what are the advantages of the cellular system? First one, we can use the low power transmitter. So for example, if you are using that cellular size is less or small cellular sizes we are used, so the low power transmitter is used for the cellular system, and it allows frequency reuse for capacity improvement. That means the same frequency channel, it is reused to the another uses. So that is the frequency reuse. By using this method, the limited spectrum can be effectively reused. Thank you.